Hi, good morning, and welcome to the ZP Developer Zone. So we like to do this Developer Zone once or twice a week, and I'm going to basically just jump straight into it. The ZP Developer Zone is all about really answering questions that have come in during the week, and they're generally the technical questions, and though sometimes some commercial questions as well. But let me go forward with this. So one of the questions that's come in this week is really about steady state versus steady state current, and I will kind of help to clarify those definitions with some examples. Somebody's interested in measuring ATP, adenosine triphosphate, and they're thinking about using this substrate or this molecule called D-Luciferin, and I will comment on that. And SPEs or screen printed electrodes are suitable for that, and I found some literature references on this. Do I believe that SPs can be used for the detection of ATP using this molecule D-Luciferin? I think yes. I think really what ZP can do is guide you a little bit through webinars like this, but us actually doing the work. I mean, at ZP, we're ISO 13485 contract developers, contract manufacturers. We have a very top of the end laboratory, manufacturing facility, all the equipment, clean rooms. But us doing work is a really kind of, these are what we generally do for other businesses as opposed to they require large budgets. But what ZP's business model does allow us to do is actually to allow some of our materials like our electronics and our screen printed electrodes to become available also to the academic market. So I think it's something that we can guide on through webinars, but we probably need a big budget in order to actually do that work ourselves. Somebody else wanted to know about measuring four measurements simultaneously, so I've got a potentiostat for that. And then the last one is about gold screen printed electrodes. I've been supporting somebody online, and I've got a lot of data and comment on their data using the screen printed gold electrodes. We do have 3 upcoming webinars, and we'll have one on really around commercialization of point of care devices. So the ATP questioner today this webinar be relevant to them, and also the person using our gold electrodes, because they're using our gold SPEs. This webinar will be pertinent to them as well. So you can, anytime you see a link jump up today, by the way, those links I'll put them underneath the video as well. So that webinar would be good for commercialization. This webinar is good for people interested in wearables. And then the last webinar is a little bit of an overlap with maybe the first one, but more of a sort of focus, not on so much on commercialization, but more on the academic sort of research side of developing electrochemical biosensors. So again, any kind of links, don't worry, I'll put them on the links underneath the video as well. Back to the question. Question number 1. I really think it's just clarifying our definitions on steady state versus steady state current. So if I take a screen printed electrode and I turn it into a biosensor, for example, glucose, what we sometimes do is we put them in a beaker. We put them in a beaker with a magnetic stirrer. When we spin that magnetic stirrer, what we're doing is we're creating a constant flow pattern. Or constant flow. We're stirring, the liquid is moving through that at a constant rate. I would describe that, the term is mass transport, as steady state. And then I can see that then in the current. So when we then add glucose, so we just add glucose here, we get a current response. And the current response is quite flat. That's a steady state current due to steady state mass transport. So I think your slight confusion over the term steady state is steady state mass transport, i.e. stirring in this case, gives you constant flux or constant movement of molecules to the surface, and you get a steady state current. And we add some more glucose, we get a jump in signal, and again, that glucose is constantly moving at a constant rate to the electrodes, and I get a steady state current. And again, we add some more glucose and we get a steady mass transport of glucose molecules to the electrode, and I get which is under steady state conditions, and I get a steady state current due to that. So I just wanted to I remember when I was kind of learning these terms as well, people talk about steady state and steady state current. Steady state describes essentially the movement of analyte, and it's under steady state, i.e. constant, and therefore you get a steady state current. And just it's a subtlety in terms, but the current comes from the steady state mass transport. You get similar things. I mean, when you look at cyclophotometry, it is not under steady state. The diffusion of molecules to that surface is changing throughout that experiment. But if you did the same experiment on a rotating disc electrode, this time rather than me stirring, it's the electrode that's moving, but it's producing a constant flow and a steady constant flow of liquid to the surface. And again, you get this one is not steady state because we're not stirring enough. It actually dips down a bit. But when it's stirring enough, then you start to get these kind of flat currents. So steady state current comes from steady state transportation of liquid and molecules to the surface. Question number 2. Guy wants to detect ATP. Adenosine triphosphate is a biomarker for bacteria. And here he's got Photobacterium leiognathi. I hope I pronounced that correct. I do think SPEs or screen printed electrodes are suitable. I will recommend our gold electrodes. And as I say, ZP is probably too high a cost center. We would kind of run with generally larger budgets with clients. So with a bacteria, ATP is the biomarker for it. Now with a SPE and a gold SPE, it is sensitive to oxygen. So what I'm going to try and do is I'm going to try and link the fact that gold SPEs and the fact that bacteria give out ATP. I want to link those two facts together, let's say. So you can detect oxygen on a gold electrode by applying a potential of about minus 625 millivolts. If you have the enzyme Lucif, then Lucif will react with the substrate that you're interested in, which is delta-luciferin, with D-Luciferin, and give you this deoxyluciferin. But for that reaction to run, you need, interestingly, oxygen and ATP. So essentially, yes, you can link. You were interested in this particular substrate. The bacteria gives out ATP, and oxygen is naturally in the solution. And in that reaction, ATP becomes AMP, adenosine monophosphate. So you can monitor the oxygen concentration on the bioreactor, and as the oxygen is consumed by this enzyme reaction, then you will see the change in signal. So these are oxygen signals that we gathered at ZP. We gather them at minus 625 millivolts by using amperometry. This is before we deoxygenate the solution, and then when we deoxygenate the solution, the signal drops quite a lot. Now, your drop in signal is going to be linked to this enzymatic reaction, essentially between ATP, luciferin, and oxygen. So I don't know if you're going to get such a big signal as this, but you're asking whether it's possible, and the answer is it is possible to detect ATP using this D-Luciferin, but you need the enzyme, and you'll be detecting it essentially through this oxygen, and the oxygen will deplete as the reaction runs. So here's the gold electrode, and really importantly, get one of these connectors, which is linked to question number 4 today, that somebody is struggling, and I think they just got poor connections. So links underneath the video. Somebody else just wants to run 4 biomarkers in parallel. At ZP, we do have the EMA potentiostat. It's a 6-channel instrument. It's pretty cute. This is it here, just in the background here. And we use it to run parallel experiments, let's say, at the same time. So have a little look into the EMA potentiostat, and I'll put a link to that underneath here as well. As I say, we generally do technical here, but this I would suggest is commercial. But we also use this to support our clients. So now I'm going to support a client. So this client has got our gold SPEs. These are the best gold SPEs in the world. We use them all the time. Even today, the batch of SPEs that this person is using, we're using them with a really large client to help them actually kind of go towards market, and that means FDA regulated products. So we put these into programs that are actually on their way to the FDA. First thing to notice in the most recent data this person sent me, so they sent me the data and then I asked them to send me an image of their setup. See, I'm not sure, maybe they've mislabeled this, but it says here current milliamps here. The current that they're putting through this experiment is equivalent to the current that you'd get off a charger. You know, if you're charging up a mobile device or something, they're basically putting through half an amp, 500 milliamps, if not, you know, it's a massive amount of current in the world of electroanalytical chemistry. There's something going on. I've seen your experimental setup. I really think you have a connection issue going on with this. You may even have a potentiostate issue because this current is just phenomenal. I mean, it's very, very high. You've sent me some images of the SPE. The way you set up the experiment, I can see that you're using external reference and external counter, but I can see from the images that at least the counter electrode is being also oxidized at the same time. So I can tell that this connection is not good, and I'll dig into that a little bit deeper in this. So you sent me an image. I do appreciate when people do send this kind of stuff because it does help me troubleshoot. You know, there's no point in not sharing stuff with us because we can't help to troubleshoot otherwise. I don't like. I'm not. Well, anyone who's really trying to do precise, let's say, analytical electrochemistry, crocodile clips are not good. They give you a very irreproducible connection, and they can be high impedance. But that said, you're clipping onto there with crocodile clips. I think clipping onto the counter electrode as you're doing and clipping onto the reference electrode as you're doing is fine. I did obviously check your colors up, so I knew that you would connect in. Now this is your working electrode, and it looks like your crocodile clipping or alligator clipping onto that working electrode. That is probably a really massive no-no that is there. And I've said you've sent me the images. Now there's a video link here. I'm going to put this video link under here as well, because at ZP you'll see this in a minute that we test SPEs when we manufacture them. We also use them, so we're constant. And then actually I'm supporting other clients as well. So this link you'll find useful because this client is also using the SPEs that you are using, and they're getting. I'm supporting them because they've got some problems, let's say, but I can see the beautiful cyclic voltammetry from them. In this case, they're using ferrocene, and I've been advising them because I could see that their experimental setup was actually pretty similar to yours. That they had the working electrode, and they had the reference electrode, and they had the counter electrode. They had a slight different. They were actually connecting using I would suggest a more professional connection here. But I was advising them because I could see that they had some problems because, like you, they're not meant to be using the counter and reference. But actually, I could see them significantly getting oxidized in their experiment. So, like you, they weren't really singularly connecting onto the working electrodes. So they were meant to be connected onto the working electrodes, but I could see that the darkening of this meant that they were also connecting onto the reference, and the darkening here told me that they were also connecting onto the counter electrodes. So I was, they were using this particular connector, and I've had to get them off this connector because this connector basically has it comes from another company. It has a 10mm slot in there, but the SPEs here are 7mm, so it wasn't basically aligning correctly. So I advised them to get a different connector, which they actually went ahead and did. So thank you so much to them. And the connector that I'm advising here, it has 2mm banana plug connectors here, which works. And I got a strong suspicion from the photos that the person who's having problems at the moment also has 2mm connectors because of the potentiostat that they're using. And it has a 7mm slot in the front so that the SPE can connect into it. Now I say this, but as ZP, we're not just, we check all our SPEs when we manufacture them, and we do a lot of testing, more than I would say any other company, and we've got a very professional way of doing data analysis on it. So this is the batch of SPEs that this particular person currently is actually struggling with. And we're also testing with 5 millimolar ferricyanide as well. And these are beautiful and reproducible, so I'm very happy with them. And we're actually using them in the lab at this moment to develop products to going towards the FDA as well. So, you know, not only do they get tested at the time, they're also in constant use at ZP as well. So just to go back to the problem we're talking about at the moment, which is this person's getting, now they're getting really high current. But actually previously they've also sent data, and I have supported. And it was like, here, I suggested here that you had a really poor connection problem. I mean, this is very distorted. When you get data like this is like having a resistor. It's acting like a resistor because it's just following Ohm's law. That, so for every application of potential, you get a current, you change the potential, you change the current, but you're changing it in a linear fashion. This is Ohm's law. It often strikes to high impedance connections at that point. So that's very much in contrast to what we get. We get beautiful. And so you have previously tried this. So I think it just comes down to, at a minimum, you've got a connection problem. You may even have a potentiostat problem. The potentiostat's harder for me to solve because that's a third-party instrument. But I think primarily the problem is actually your connection. So what you're trying to do is you're trying to clip onto this here using this guy. There may even be a case, I got a strong, there may even be a case that you're actually making liquid contact with this crocodile clip, with a liquid solution, that is. So you're trying to clip onto there. And I can tell from your photos that you're not, or you are, but you're also, see, the way you've set this up, that counter electrode should not in any way be in the circuit, but it's so darkened, it's clearly been, I think you're clipping onto the working and also catching the counter as well. And then in other images, I think you're clipping onto the working and also catching the counter and also catching the reference electrodes as well, because these are also very darkened up as well. So I think your connection is really your biggest thing. So I'd suggest that if you have to get a professional connector, I'm afraid, at a minimum, which I'm now suggesting. So question number one, steady state versus steady state current. Steady state, when people use that term steady state, they're probably more referring to steady state mass transport, when you've deliberately created a situation where the solution is constantly arriving at the electrode, which then leads to steady state current. I like your idea about detecting luciferin on the SPE. It will work. And I'll suggest a gold electrode for you. Doing in simultaneously or in parallel is the potentiostat, and that gold SPE. As I say, I mean, I've got about 4 bodies of evidence here. Well, I've got 4 case studies here. Before the screen printed electrodes are shipped, ZP is really good at testing them. I have another client running in Europe at the moment, exactly on the same batch as you, and we're also in Europe and testing on the same batch as you. I've shown their data in this webinar, so you can see their beautiful data. And with them, I was only improving them a little bit by giving them a connector. The currents that you are passing are massive. There's something going wrong here, and it's not, unfortunately, on the SPE. I suspect it's on the connector. Primarily, it's on the connector before you start troubleshooting that potentiostat, but primarily it's the connector. Until you sort that connection out, you can't troubleshoot anything else. So if you've got any questions on ZP, don't hesitate to contact us. Okay, thanks very much.